Okay, we've got our lesson 5.13 on classifying angles, our Common Core 7th grade Geometry 5. I've already written out our vocabulary for you right now. Talking about our adjacent angles, some things that you definitely need to know is that our adjacent angles are angles that have a common vertex and a common side, but they have no common interior points. So let me go ahead and explain to you what I'm talking about here. If you look at these two lines that cross each other, I have 4 different angles. Angle 1 and angle 2 are adjacent angles because you can see they have a common vertex. They both have that point right there. They touch each other at that vertex. And they actually have a common side. That common side is right here. They share that one side of the angle. But notice all the points that are in here do not touch any of the points that are in here. There's no common interior points. So I'm showing you that angle 1 and 2 are adjacent. Angles 2 and 3 are adjacent. Again, notice they have that same vertex right here, and they share the side between them, and nothing is in their interior points do not overlap. 3 and 4 are also adjacent because they have that same vertex, but this is the side that they share, and again, no common interior points. And angle 4 and 1 are also adjacent because they have that same vertex, they share a side, and none of their interior points are in common. But when I look over here at this one, I see that's not adjacent because, I like my clock so you know what time it is, not adjacent because they have no common vertex. Vertex for 1 is here, vertex for 2 is over here. So they don't have the common vertex, and notice all the points for angle 1 are the same as all the points for angle 2. So those are not adjacent. Vertical angles. Well, our vertical angles right here are angles that are non-adjacent. They are not next to each other. They're formed by 2 intersecting lines. They're basically vertical angles, so they're diagonal across from each other. But what I love about vertical angles is you can see right here that vertical angles are congruent. And I'm showing you what that congruent symbol looks like. It's that equal sign with a squiggle on top. It means that they are the same. So if I gave you this nice little angle, two lines are crossing each other, makes those 4 angles, 5, 6, 7, and 8. I'm telling you here that angle 5 is a vertical angle to angle 7. And since they are vertical angles, they are the same. They're congruent. So I put it over here that angle 5 and angle 7 are vertical. So just an example, if angle 5 was 110 degrees, that means I automatically know angle 7 would also be 110 degrees. And then, of course, I've got over here angle 8 and angle 6 are vertical angles. And since they're vertical, that means that they would also be equal. So if 6 and 8 are vertical, if I knew that 6 was 70 degrees, that means 8 would also have to be 70 degrees. So looking at this example here, I'm trying to find the missing angles. I already told you that A was 70 degrees. I gave it to you. And if you look at it, you know vertical angles are the same. So if A is 70, the vertical angle right here, angle C, is also going to have to be 70 degrees. Now, I know that D and B are vertical, but I don't know what D is. I can see, though, if I put A and D together, they make a straight line, which means that if I take 180 degrees, which is a straight line, and I subtract what A was, which was 70, that's going to give me 110 degrees. So I now know D is 110. Well, if D is 110 and vertical to B, that means B is 110 degrees. Now we're going to look at some different angles, complementary angles. And complementary angles right here are two angles that when I put them together, only two, I can add and they will be 90 degrees. So I'm telling you with this example here, if this one's 65 and I put it together with this 25-degree angle, you can see if I actually was able to pick them up and put them together, it would give me that 90-degree angle. 25 and 65 is 90. 90 degrees, two angles that add to be 90, are complementary. And we all like compliments. It makes us feel good, doesn't it? Well, that's because a compliment is the right thing to do. Do you get it? A compliment is the right thing to do. 90 degrees is a right angle. So that's one way I always remember. Supplementary angles, though, little different. Supplementary are also two angles, only two, but when I put those together, they're going to give me 180 degrees. So here I've got a 120-degree angle. And with that 120-degree angle, here's a 60-degree angle. And if I was actually able to pick them up and put them together, they would give me that nice straight line right here. 60 and 120 is 180, which is a straight line, and that would be supplementary angles. So if I gave you an example and I said, find the complement of 75 degrees, complement, remember, is the right thing to do. I need to have 90 degrees to be a right angle. Subtract the 75 I just told you that you had, and when you go ahead and do that, you should have 15 degrees. The complement of 75 is 15. Looking at the next one, if I said a supplement, supplement means I'm going to get a straight line. Straight line's 180 degrees. 180 minus the 95 that you can see that we have right here means that the supplement would have to be an 85-degree angle. So that would be the supplement. Now just to go back and review about our adjacent angles at the top, if I gave you these, would you say they are adjacent or not? And if they're not, why wouldn't they be? So look at this first one here. I've got two angles, angle 1 and angle 2. Would they be adjacent? Do they have the same vertex? And do they share a side? They do. And then when I go ahead and look at actually the interior angles, would their interior angles have any that would overlap, or are they separate? They are definitely separate, no common interior points. So yes, these are adjacent. Let's look at the second one over here. Now over here I've got angle 1 and I've got angle 2. Are those adjacent angles? I'm hoping you would tell me no. And why? I need to know why they don't. Well, look at, first of all, look at that vertex here and a vertex here. Are they sharing the vertex? No common vertex. Now, they do have a shared side, but if I don't have a common vertex, it doesn't matter if they share a side. It's still no. Their interior angles, they don't have any common points, so that even doesn't matter. Again, if I don't have a common vertex, it doesn't matter if the rest of the things are true or not. This would be a no. Now let's look at this last one. Would this be considered adjacent angles? I've got angle 1 here. Angle 2 is this whole piece. Well, let's check it out for a second. They definitely have the same vertex, so that works. Do they share a side? Well, Yeah, they kind of do share a side right here. This side is the same for 1 and the same for number 2. They both share a side, so that definitely works. But the interior points is a problem. So this would be no. Remember with the, let me look back up here really fast. They have to have no common interior points. And we could see in that one right there, it is definitely a lot of common interior points. All these points overlap with all these points. So they have common interior points. That's what makes them not adjacent. So hopefully you've gotten those notes down. We'll be working on this together in class. If you have any questions, write them down and we can cover it when we meet. Have a great day.